Hello friends, welcome to Physics with Ben. Don't forget to subscribe, like, comment and share this video. You may also love to turn on the notification bell so that you can always get notification anytime I upload a new content. You may love to click in the description on this video you are watching to watch the full 1 hour video, power pack video on frictional force, the theory, the equations and everything. In that video I promise this video you are watching right now, calculations on frictional force. You have to go back to that video you have before you have to come back to this video, because every equation in that video is used here today. So without wasting much time, let us go straight to the business of the day. We want to look at calculations on frictional force. Let's solve question number 1. A force of 20 Newton applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 4 kg move on the table. Calculate the coefficient of friction between the block and the table. Take acceleration due to gravity to be 10 meters per second squared. So as I always tell us in all my calculations, first things first, the 5 C's of calculations. So we are going to collect our data. So we'll write solution to question number 1. Good. We're going to collect our data in form of drawing. So we are going to draw this question. So the block weighs 4 kilograms. The block weighs 4 kilograms and the force of that applied prior to that. So this force, which is supposed to be my pull force, is equals to 20 Newton. And then the weight of this block is equals to mass times gravity. And up here is your normal reaction. So if the block pulls this guy this way, so the frictional force will act this way. So this is my F, my frictional force. And in between here, the coefficients of friction, the mu. So they ask us to calculate the coefficients of friction. So given that F is equals to mu R, where mu is the coefficient of friction. And from here we know that the pull force is equals to the frictional force. So we write that the pull force F is equals to the frictional force. So this frictional force is equals to mu R. And so we also write that the normal reaction R is equals to the weight of the block and is equals to mass times gravity. So we write again that from this equation, the frictional force is equal to the pull force. And so we write that pull force Fp is equals to mu R. So we make mu the subject of the formula. So this implies that mu is equals to frictional pull force divided by normal reaction. So this is the pull force divided by the normal reaction. And the pull force is 20. So 20 Newton divided by 4 times 10. So mu is given to be, and that will be in Newton. 20 Newton divided by by 400. Divide by 400. This go. So we are left with 2. Newton will go with Newton. So we are left with 2 divided by 40. 2 here 1, 2 here 20. So mu, the coefficient of friction is given to be 0.05. This is our answer. So therefore, mu is 0.05. Remember, mu has no SI unit, and that is our answer for that. Question number 2 reads, when a box of mass 45 kg is given an initial speed of 5 meters per second, it slides along the horizontal floor a distance of 3 meters before coming to rest. What is the coefficient of the kinetic friction between the box and the floor? Very, very simple. So we are still going to do the same thing. We are collecting our data in form of sketching the diagram. So this is question number 2 solution. This is how the diagram looks like. So the box, good. So the box weighs 45 kilograms. And don't forget the weight of the box, W is here, mass, that's gravity, and up here, the mass is always equal to the normal reaction. And the box, let's read again, slide horizontally, was given a push. It's a velocity, right? So this was, velocity is a vector quantity with both magnitude and direction. So that is for the velocity. And our initial velocity u is given to be 5 meters per second. And so the bus moves to a distance of 3 meters, somewhere like this, somewhere here. It was given a push, and then something like this. Good. So it slides and then it stopped because of frictional force on the surface. That is exactly what you saw there. So if that happens, they ask us to calculate the what? What is the coefficient of the kinetic friction? So the frictional force will act this way. That our frictional force F mu is equal to that mu R. And our mu, our R, our normal reaction is equal to mass, that's gravity. And this normal reaction from this equation also means F over mu, F all over mu is also our equation here. So now let's calculate. So here is also a pull force. So we write that our frictional force is equal to pull force, and our pull force, don't forget this body also moves with an acceleration. Our pull force is mass times acceleration. Mass times acceleration. So we write that our frictional force is equal to our pull force, and then our normal reaction is equal to the weight of the block. So we are going to find our friction. We are going to equate our mu r to be equal to the pull force. And in this case, our mu r also means our pull force is a mass times acceleration. So, and we also know that our normal reaction R is equal to mass times gravity. If you do that correctly, let's just do it. Our normal reaction R is 45 times 10. That will give us 450 Newton. That's our normal reaction. Now, from the equations of uniformly accelerated motion, we know that v squared is equal to u squared plus 2as. Good. And this s means distance. This a means acceleration. Are we good? So, if we plug in these values, we are going to find our acceleration. Acceleration is not given here because we are going to equate. This is the equation we are going to use to solve for this. This is the equation here. We need to find our acceleration. Acceleration is not given. We have found our normal reaction to be 150 Newton. And then we're going to make mu is sort of the formula. So from here, we're going to find our acceleration. So since the initial result was given, it means that our final result was 0. So we have it that 0 is equal to u squared plus 2as. So this implies that minus u squared is equal to 2as. So our a is equal to minus u squared. Our a is equal to minus u squared divided by 2s. And if you do that correctly, we have 5 squared is 25 minus 25 divided by 2 times 3. And so our a will be equal to minus 25 divided by 6. So we have 25 divided by 6, and that will give us minus 4.1667. So our acceleration, this minus sign indicates that this is not actually an acceleration but deceleration. The body was moving and then it decelerated because of the effect of friction, and then it slows down finally. So our A, the minus sign here indicates that it is actually deceleration. So we write that our deceleration is given to be minus 4.1667 decimal places and meters per second square. So having written that, we're going to write that our mu r is equal to mass times acceleration. So we are going to substitute now. So we write that mu is equal to mass times acceleration divided by r. Mass and acceleration divided by r. And by correct substitution, we have that our mass is given to be 45 times. We're not going to put the negative sign there because just indicates that acceleration. So 4.1667 divided by 450 Newton. Don't forget, yeah. So this is the same thing as 45 times 4.1667. So we have 187.5015 divided by 4, 5 dots. So our mu is given to be that answer divided by 450. So our mu is given to be 0.41667 with no SI units. And that is that for question number 2. Question number 3 reads, two bodies P and Q of masses 5.0 kilogram and 7.5 kilogram respectively are connected by a light inextensible string as shown below. If P is placed on a rough surface of coefficient of friction 0.5, calculate the magnitude of 1. The normal reaction on P, the frictional force between P and the surface, tension in the string. Good. So from this diagram, I am not going to. I'm going to maybe redraw this diagram. Yes, I'm going to redraw this diagram up here for the sake of clarity. So we have something like this. I want to redraw the diagram for the sake of clarity. So this is P, and P weighs 5.0 kilogram. Good. And P is resting on a rough surface. Good. And then there's a groove here, a string. Then the mass, another mass. This is 7.5 kilogram. This is 7.5 kilogram, and this is mass Q with weight downward. And then a tension is created up here and then down here. So if you remember the video I asked you guys to watch, please click in the description of this video you're watching so that you will get more clarification on this. So this is a rough surface. So this weight is bigger than this weight. And of course, it will be forced to drag this down. So there's a tension created here. And there's a tension also here. So the resultant pull force will be in this direction, and I call that Fp, and that Fp is equal to mass times acceleration. This block will move with an acceleration. The tension here and the tension here is the same. I told us in the other video that they move simultaneously. So we're going to apply simultaneous linear equation in solving this problem. And so down here is also an acceleration. Down here, good. And take note, this acceleration and this acceleration are the same because the bodies will move simultaneously at the same time. And so the tension here is also the same thing as the tension in this place. So we also have our pull force down here to be equal to mass times acceleration. Then here is down here is the weight of this block. That weight is given to mass times acceleration. So mass times gravity. And up here is the normal reaction. And then backward is the frictional force equals to mu r. And then in between this surface is the normal, the coefficient of friction. And the coefficient of friction here is given to be mu is equals to 0.5 in between this block and this rough surface. So I think the geometry of the question is complete now. So without wasting more time, let us solve the question now. The first thing first they ask us to do is to find the normal reaction on P. So the normal reaction on P is this. You know that from here our mu R is equals to, the normal reaction on P is simply mass times gravity. This mass times gravity. So 5 times 10 will give you 50. So we write that the normal reaction on P, R on P, R subscript P. The normal reaction on P, that is R subscript P, is given to be also equals to the weight of the block P, and that is equals to that this implies that a normal reaction on P is equal to mass times gravity. By correct substitution, we have it as 50 times 10. I'm sorry, 5 times 10. That would give us 50 Newton. That is the normal reaction on P. And so the next thing they ask us to calculate the frictional force between P, the frictional force between P and the surface. The frictional force between P and the surface. The frictional force is given as F. The frictional force on P equals to mu times R. So because we have found a normal reaction, we just plug in the values and substitute. So this implies that our frictional force on P is equal to mu 0.5 times 50 Newton. And 0.5 also means 1/2 times 50 Newton. And that is 25. So therefore our frictional force on P is 25 Newton. That is that for that. The next thing they ask us to calculate is the tension in the string. That is where we are going to apply simultaneous equation. We are going to derive our physical linear simultaneous linear equation. Our physical simultaneous linear equation, and then calculate. So if you follow me in the other video I was doing, let us derive the equations here. The total horizontal net force is given to be the total horizontal net force, that is horizontal net force is given to be the tension, this tension here, this tension minus the frictional force. Good. So tension minus the frictional force. We call this equation 1A. And this also means this also means FP. This means mass times acceleration is equal to tension tension is equal to tension minus the frictional force mu R. Let's call this equation 1B. Good. So downward here we have this is weight is equal to mass times gravity. So the total downward net force, this is horizontal net force. Total downward net force is given to be, which is equal to this, is given to be this weight minus this tension. So say this weight minus this tension, and call this equation 2A. Equation 2A. Equation 2A. So if you substitute total downward net force, we have mass that acceleration is equals to mass times gravity minus tension. We call this equation 2b. So equation 1b and equation 2b are our simultaneous linear equations that we are going to use to solve this. So we are going to rewrite that. From here we have mass. Let me write the mass. That acceleration is equals to tension minus mu r. That is 1b. We also have mass times acceleration is equals to mass times gravity minus tension. That is equation 2b. Equation 2b. So we have to find the tension in the spring. So these are the equations we are going to use. For the first one, which is this, our mass is given as what? We have 5 times A is equals to T minus 0.5 times the normal reaction. You remember the normal reaction was 50. So times 50 Newton. The normal reaction was 50. Let me confirm that. Yes, I was correct. Times 50. Yes, that will be that. So if we expand correctly, we'll have 5A is equals to T minus, this times 50, you have minus 25 Newton. You call this equation 1C. So we work on the next one, which is this mass. This is downward one mass. We have 7.5 times A is equals to mass, this mass times gravity. So we have 7.5 times 10 minus the tension. So we have 7.5A is equals to 7.5 times 10, we'll have 75 times 75 minus T. We call it equation 2C. So we have 5A is equals to 7 minus 25n. That is equation 1. Equation 1C, we have 7.5A is equals to 75 minus T, equation 2C. We are going to rearrange these equations so that our T will be one side and the others will be on the other side. So we write that our T, from here our T is equals to 5A, our T equals to 5A plus 25 Newton. So this is T also equation 1C. Let's start equation 1C start. And then we also have this second one also written. We have it as minus T is equals to 7.5A minus T equals 7.5A minus 75 minus 75 Newton, sorry, minus 75 Newton. Yeah, minus 75 Newton. Yeah, 7 minus T is equals to 7.5a minus 75a. So we also call this like question number 2c star. Good. So we are going to solve using simultaneous linear equation at this point. At this point, the equation have been arranged for us to solve them using simultaneous linear equation, either by elimination or by substitution. So we are going to add equation 1 to equation 2. That is one method. Or you will solve by making a solid formula, but this is faster. Let's add the equations. So we are going to add equation 1 to equation 2. And if we do that correctly, this is what we have. So we're going to add. We are adding this equation. So this plus this will give us 0 here. Be like equation sign 7, 8, 9, 10, 11, 12. We have 12.5a. This 25 plus minus this will give us minus 50 Newton. So at this point we are going to say that our 12.5a is equals to 50 Newton. We divide both sides by 12.5, and then our acceleration, which is common to this and this, will be equals to 50 divided by 12.5, and our acceleration will be equals to 50 divided by 24. That is 4 meters per second square. So for the common acceleration these guys have here is 4 meters per second square. This acceleration is equals to 4 meters per second square. So at this point we are going to come back to equation 1c star or 2c star and find our tension. We can plug into that and find. So let's use any of the equations. So equation 1 will have T is equals to 5 times 4 plus 25 Newton. That is 20. 5 times 4, 20. So I have 20 plus 25 Newton. So therefore our tension is 45 Newton. The tension created in this string, in this inaccessible string, in here and here, tension T is 45 Newton. Our T here also is what? 45 Newton. That is that for that. To this we have come to the end of the solution on question number 4. You may love to screenshot. So let's solve question number 4. Question number 4 reads, a concrete block of mass, a concrete block of mass 35 kg is pulled along a horizontal floor with the aid of a rope inclined at an angle of 30 degrees to the horizontal. If the coefficient of friction is 0.75, calculate the force required to move the block over the floor. So we are still on question number 4. Solution to question number 4. We are going to collect our data through drawing. So this is what we have. We have this. And the block weighs 35 kilograms. And it is pulled with a rope inclined with the horizontal, and this rope is 30 degrees to the horizontal. So the force that will lift this off the floor is this force. This force is not given. So we have this force as a resultant force, and this as the horizontal component of this force. And up here as the vertical component of this force. And the normal reaction, the weight of the block will be in the downward direction. The weight of the block W is equal to mass, as gravity is there. And up here is the normal reaction R, and here is the coefficient of friction, and it's given to be 0.75, and right here is the frictional force. So all the parameters are represented now, and this is the surface with which this block is resting upon. So this is a sketch of question number 4. So the next thing we are going to do, we are going to generate the equations that are needed here. First up, let's find the horizontal components of these forces. So the horizontal component of the forces, I call it FH, horizontal components of the forces. The resultant horizontal components, of the forces, FZH, is given to be what? We have a frictional force is equal to this Fx, or we write that our Fx is equal to the frictional force. We call this equation number 1. Good. So let's go to the downward part of it. The weight, you may love to click in the description of this video you're watching to what the theory on this question. So our W is equal to R plus F. So the vertical, right? The vertical component. So the resultant, sorry, this is RZ. The resultant vertical component of this force is given to what? W is equal to the normal reaction plus Fy. We call this equation number 2. So we are going to throw more light on equation number 2. So this force is the same thing as F sine theta, and this force is the same thing as F cos theta, and F is equal to mu R, and R is the same thing as what? We'll not look at that for now. So let us clean this side and solve the question properly. Good. So from here we write that for equation 1, we write that our Fx, which means we have our Fn, which means F cos theta is equal to Fm, that's friction, mu R. We call this our equation 1a. Secondly, our W means for mg, so we have our mass times gravity is equal to R plus Fy, means F sine theta. So we call this equation number 2a. We see throw more light to that. So we are going to work on equation number 1a again, and we now write that we are going to flip that and make R the good. We have to find this force, this. So we are going to do it this way. We're going to make R the solid of the formula here, and let's substitute first. So our force here we have just the same thing. We have our force, we have F, our F cos 30 is equal to mu. Mu is 0.75 times R. We call this equation number 1b. Also, mass of the block, we have 35 times 10. 35 times 10 is equals to R plus F sine 30. Call this equation 2b. So if we still work on equation 1, equation 1a, 1b, and 2b, we see arrive at an answer like this. We have cos 30 will give us, so we have 0.866 F is equals to 0.75 R, equation 1c. Still here we have 35 times 10. Take note, this is give us negative 35 times 10. We have 350 Newton is equals to R plus sine 30. Sine 30 will give us 0.5 F. Call this equation 2b. So at this point, we are going to, now because of this arrangement, we cannot say that the W is equal to normal reaction here. Take note of that. Because of this arrangement, we can't say that W equals to what? R. Because both of them shares a normal reaction now. So we're going to make R the solid formula in equation number 1c, and then substitute back here to find the force, this particular force that will lift this guy, this load up. So from here we write that our R is equals to 0.866 F divided by 0.75. Do that correctly, you have 0.866 divided by 0.75. We got 1.15467 F. So we are going to put F in equation 2b or F in equation 1c. So for equation 2b, we write that any place you see R in equation 1b, we are going to put this value. So we write that we have 350 Newton is equals to 1.15467 F. 67F plus 0.5 F. So 350 Newton is equal to that, the answer plus 0.5. So we have 1.65467 F. So we now make F this F, the subject of the formula. So write that F is equals to 350 Newton divided by 1.65467. Do that correctly. Well, 350 divided by that. We have 211.52 Newton. So this is our correct answer. This force that we lift this roof up is 211.52 Newton. As simple as A, B, C. Don't forget to subscribe, like, comment, and share this video. The next is question number 5. I love to clean this. Good. Question number 5 is the coefficient of static friction between a 40 kilogram crate array. The coefficient of friction of static friction between a 40 kilogram crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base inclined at 45 degrees to the horizontal. We are going to collect our data with a diagram. So this is the concrete base inclined at an angle 45 degrees. The crate is here, and the crate weighs 40 kilogram. 40 kilogram. And dimensionally, if you follow the other video I did on this, here is the weight, mass times gravity. The resultant weight is here, and right here is X, and right here is that, and down here is WY. Good. And so if the crate will have to slide down naturally, then the frictional force will act this way. So this is our frictional force. So this question has a controversial answer, and I am solving it based on what I understand. The minimum force that will keep this crate stationary, it means we are calculating a question on static friction when a body is at rest. By static friction, we mean the forces are zero. The push force is equal to the frictional force, and the body will not move. A body can only start moving when one force overcomes the other force. When the frictional force overcomes, and when the pull force overcomes the frictional force. So if this crate must be kept stationary on this platform, it means that the surface is rough, number 2, and it means that the frictional force is equal to the vertical component of the weight of this block. And so we write that WY is equal to the frictional force. And so this frictional force is the minimum force that will keep this crate constant. Please, this question is controversial. If you have your different opinion on this question, you can drop the answer or your opinion in the chat box. So for me, this is how I am going to solve it. And we know that WY is equals to W sine theta. And so we write that the minimum force, which is the frictional force acting in this direction, will be equal to the weight this is mass times gravity times sine theta. If you substitute correctly, you have your mass as 40 times 10 times sine 45. If you do that correctly, you are going to have so we have 400 times 0.7071. So if you do that correctly, we have 400 times 0.7071. 0.7071. So my calculation on this channel is 282.84 Newton. So for me, this minimum force that will keep this guy stationary is 282.84 Newton. Any other controversial answer is welcome. That is why we study science. Constructive arguments are welcome. Please don't forget to subscribe, like, comment, and share this video. If you have watched this video from the beginning of the theory on frictional force, which I asked you to see in the description box, down to this level, then I bet you and then I charge you up. There is no question under this topic, frictional force, that you cannot solve, because the questions were carefully selected in all the areas I have treated in the theory. I have selected the questions based on the 5 methods of finding the coefficient of friction. To this, we have come to the end of this video. Thank you and God bless you. Bye-bye.